in this video I am going to discuss another question, binary tree maximum path sum. So what they are trying to ask in this question is, let's say I'm given this small binary tree. So what is maximum path sum here? So maximum path sum is 2 plus 1 plus 3, which is 2 plus 2 plus 2, 6. So 6 is our answer for this tree. Let us take one more example. 1, 2, 3, 4, 5. Okay. Now what is maximum path sum here? One of the path sum is like this. Okay. So this is 4 plus 3 plus 5. So it's basically 4 3s are 12. Now another path which I can explore is 2 1 3 5. 2 plus 1 plus 3 plus 5, which is 2 3 is 6, 6 5 11. One more path is 2 1 3 4. 2 1 3 4, which should be 10. Okay, so which is the maximum path among this? Can I say this is the this one is the maximum path? I can say that, right? So this path gives you the maximum sum. So it is pretty clear that it's not necessary that the longest path which is in here will give you the maximum sum, but you need to check maximum sum for every node. Okay, just like what we did in the previous question, if you remember. If you're not, no problem, I will recall it. So in this diameter question we used to have a variable d, or we can pass it by reference as well, which was basically storing diameter at every node. Similar thing we have to do in this question. As I just told you in the example, that it is not necessary that the maximum sum is like you will be getting like this or like this. It's not necessary. Maybe the smaller one, the smaller path will give you the maximum sum, right? So this path was giving us the maximum sum. Now what are the other paths? Let me change the example a bit. Okay, so 1 1. Okay, so in this case 2 1 3 1. Okay, 2 plus 1 plus 3 plus 1. This is how much? 2 2 4 7. And one more path, 2 1 2 1 3 2. 2 plus 1 plus 3 plus 2. This is how much? Just one greater than it, 8. Okay, 2 1 3. This is one more path, although this is not our answer, but this is one more possible path. 2 plus 1 plus 3. 3 plus 3 6. This is also one of our part. 2 and 1. 2 and 1 3. This is also one of our path, but the maximum path which I will be getting is this. Okay, so basically if I am getting positive numbers, so adding positive numbers will always give me a bigger result, but adding a negative number with a positive number will eventually decrease this positive number. So I can say that for example in here I had positive numbers here as well, so I wanted to include these numbers. For example, this path sum, or maybe this path sum, you can say uh, this path 1 path 2. So this path sum was like 1 plus 3 plus 2 or 1 plus 3 plus 1. So it was positive number, it was a positive number, so I wanted to include it. Okay, so here this is coming out to be 3, and if I would have included 3 plus 2, which is 5, so I will be getting a better result. If I will be adding 4 to it, so I would have got a bigger result. So can I say that add, if I have positive numbers, I will welcome it. But if in case I have negative numbers, for example, let me remove it and write everything again. 2 3 and minus 4 minus 5, minus 4 minus 5, okay. 1 2 3 4, minus 4 minus 5. So in this, oops, 1 2 3 minus 4 minus 5, okay. So here, as you can see that if you include this minus 4 with 3, you think your answer is going to increase? No, right? If you do 3 plus minus 5, you think your answer is going to increase? No, right? So do you think, is it really worth it adding minus 4 or minus 5 to your answer? No. So can I say that if I am getting a negative answer, it's better not to include it, right? If I am getting a negative answer, better I should not include it. Yes. So the best path which I will be getting is not 2 plus 1, not 3 plus 1, it's 2 plus 3 plus 1. 2 plus 3 plus 1 is 2 4 6, and not, definitely not this 2 plus 3 plus 1 minus 4, which will be 2. And if you consider uh, this path, so it will be 2 plus 3 plus 1 minus 5, which will be 1. So definitely 6 is a bigger number. 2 and 1 is smaller number than 6. So I will not consider these parts. Better I will consider 0 in place of them. So in case of negative, it would be better if it was 0, right? Okay. So we basically got an idea that if we are getting some negative note, better not to include it, or you can say better make the sum positive, sorry, 0. If you are getting positive notes, wow, then add it. Surely you can add it. If the path sum, you how the path sum is made, you got to know about that. Also, the path sum, you got an idea that you have to choose the path 3 4 5. So you have to choose a path. Of course, there are, it's in this direction. So either you can choose this path or you can choose this path, either this path or this path, okay. So basically you are what you are trying to return, you are trying to return maximum of left, or if it right, means if left was giving you better sum, so I will definitely say left. If right was giving you better sum, I will say definitely right. And also I will add the root in it, so root dot value. Okay, now let's see this code. uh, yeah, left side, on the left side you can see it's a wrong code, but on the right side you can see it's the right code. So what's the major difference? Okay, let us first see this code on the right hand side. The right hand side code is the public here. So first I have made sum is equals to 0 means basically I could have taken 0, but I took it this. What was in case of root is equals to null? I could have taken 0. But these are the cases which you can manage according to the test case which are failing. You can modify the code accordingly. This is just a basic template just to give you understanding that how this code is gonna work. In different platforms they may have uh, different test cases, so accordingly you can modify the code. Okay, so in this question also I am trying to pass sum as reference, means I will be storing the maximum sum uh, basically from every node. As I told that it's not necessary, the maximum sum will always lie like this. It may happen that the maximum sum is here only. So to consider this path, we should always, for every node we should check the sum. So that is what we are doing in this line. We are checking left sum, right sum, and this node's value. If we add the all the three, basically 1 2 3 4 5, so left, left, right, well. Okay, so I am checking, uh, I am adding all the three and checking if the sum is greater, so update the sum value. Otherwise, okay, let the sum value be there, whatever it was earlier. So basically I am using maximum depth code in this question also. So in this question, just like in maximum depth question, we used to say maximum of this and this, and here, and then we used to write +1 and then used to return. But in here we are returning val. Okay, that is the simple difference between that code and this one, and both of them are giving the paths. The single path, as I have written in the comment, returns the maximum path sum from this node 1 2 3 4 5. So if it was this path, if it was on 3, so it would have given this thing. The sum would be computed for 3 4 and 5, but only 3 plus 5 would be returned. It would be like 4 comma 5 plus 3, maximum of 4 comma 5 plus 3, which is definitely 3 plus 5 is equals to 8. So 8 will be returned. But for the maximum sum, for the maximum sum in this line, it will be like 5 plus uh, 4 plus 3 plus 5, and initially whatever was the sum, I don't know. So it would be taking out maximum of that and this. So you got the idea that when we are returning, just like the code in maximum depth, there we used to return the maximum depth of the single path. Similarly in here also we are returning maximum depth of a single path, not like this the mistake I did earlier, where I did LH plus RH plus val also. It's not like this. Okay, this is why I have written it's the wrong code. You don't have to return like 3 plus 4 plus 5. No, you don't have to do like that. You have to only return the maximum path, sum of maximum path sum. And similar thing you have to do when you reach the node 1. So again you have to see that which path is giving you maximum. So in that case, this let me again change the pen color. Okay, so this thing 1 plus 3 plus 5, which is equals to 3 plus 5 8 9. So 9 will be returned actually from this complete tree. 9 will be returned, but this condition, this sum condition would have checked, okay, maybe 9 will be returned, but this is the maximum path, which is 2 plus 1 plus 3 plus 5. This is how much? This one already we calculated, it's coming out to be 9. 9 plus 2, 11. So 11 is the maximum sum of the tree. Even though it's returning 9, this tree is returning 9, but the maximum sum is stored in this variable, which is sum only. So this is what we are trying to return. You got my point? So hope you got my point. Hope this question is pretty much clear to you. Make sure you this code to use the code of maximum depth, and not to return code like this where LH plus RH was this thing. Just make sure you return the maximum path sum of this node. Make sure you check the sum for every node, because any node can give you the maximum sum. You can pass sum like this, as I have told you earlier. And this is pretty much it for this question. I will see you in the next one.